Hello guys, welcome back. Today I'm introducing a new topic which is a moment in engineering science. And for those who are doing engineering science, this is a work for you. For those who are encouraging, indeed, right? Uh, Today we are going to be finding how to find the moment of certain of this question which we are having here. We have the diagram and we have the forces. These are the forces which we are having here. We have force 1, it is equals to 100 Newton, 10 Newton. And force 2, we have 15 Newton, 15 Newton. Then force 3, we have 25 Newton. And we have the resultant force, which is acting upwards, which is RA and RB. RB, it is equal to 30 Newton. And we are told to find RA. How do we find RA? In finding RA, there are conditions which you must follow in moments. Let's say condition here. Conditions. There are conditions, the sum of forces should be equals to 0. There are also sum of moment should be equals to 0. Sum of forces, this means that forces acting upwards is equal to forces acting downward, right? Then if you take a force acting downward, the forces acting downward, it is these forces which you are seeing here. The forces acting upward, these are the forces for RA and RB. And the forces acting downward, it is these are which you are seeing here. These forces usually found on, let's say, let me try to draw a motor vehicle here. Let me just draw like a simple vehicle here. I don't know if it will be. And it has a chassis here. Then the wheel. Then in this motor vehicle which you are seeing here, this motor vehicle which you are seeing here, there are some forces which are acting upward, and there are also some forces which are acting downward. Because for it to be stable, that means the forces acting upward should be equal to the forces acting downwards. So this applies to the conditions of moment. This is a condition of moment. Like I say, force acting upward minus forces acting downward should be equals to 0. This is the first condition which I'm giving you. And for sum of moment, that means clockwise moment should be equals to anti-clockwise moment. So that means when anti-clockwise moment crosses the equal sign, it is going to be minus. So we have a clockwise moment minus anti-clockwise moment should be equals to 0. And for you to solve this kind of question, you must know the condition of moment. So we are going to take, for this question, we can take the first part, the sum of forces, because we have the forces acting upward and the force acting downward. So let's take the first condition here to solve this question which we're having here. The question we have, we have F1 equals 10, F2, which is force, equals 15, and the F3 it is equals to 25 Newton. And we have to find Ra. How do we find Ra? When we stand here, so that means we are going to say forces acting downward should be equals to forces acting upwards. So in which we're going to say when you add these forces should be equal. So F1 plus F2 plus F3 should be equals to the forces, or here F3 should be equals to the forces which are acting upward, right? So in which the forces acting upward, we have Ra plus Rb, right? Force 1, we have 10. We are taking this condition for the first, the sum of forces. Like I say, the forces acting upward should be equals to the forces acting downward. So this is the formula which we are using here. So plus force 2, we have 15, plus force 3, we have 25, which should be equals to Ra. Because we are looking for Ra, so Rb, we have 30 Newton. And here we can't add because here there's a variable. It can be x or any variable. In which here 15 plus 25, it is 40. So we are going to have 10 plus 40, which is equals to Ra plus 30 Newton, right? 10 plus 40, you are going to have 50, which should be equals to Ra plus 30 Newton, right? Then Ra plus 30 Newton should be equals to 50, right? Then when you subtract 30 both sides, you are going to have Ra equals to 50 minus 30 Newton. This is Newton even here. So Ra, it will be equals to 50 minus 30, it is 20 Newton. So for this moment, this beam to be balanced, that means for this beam to be balanced, that means here there's a 20 and here there's 30. Okay, this is how we find the forces acting on certain object. And I've shown you how we can find forces using this condition, which is the sum of forces should be equals to 0 and sum of moments should be equals to 0. And if from this equation we have used sum of we have used sum of forces. Like sum of forces, it is equals to forces acting upward should be equals to forces acting downward. So now let's move on to question 2. Question 2, the diagram, it is like this one. Question 2, the diagram, it is like this one. We have the forces acting downward, which is 200 Newton. Then another forces, which is 300 Newton. Then other forces, which is W. And this one, the last one, it is 100 Newton. Then here the distance from 300 Newton to W, it is here we have a fulcrum. it can be a river. This is a kind of a river. So we have here we have a 0.25 and here 0.1. Then the distance of which this beam is subjected to, it is like this one. Here we have 0.3 meters. Here we have 0.4 meters. And we are asked to find this W which we're having here. So for us to find this W, we have to use both. We have to use both condition. For summation of F should be equals to 0. A summation of moment should be equals to 0. So we have to use this condition here. So first of all, let's use first this condition here, the sum of moment. Like I say, the sum of moment should be clockwise moment minus anti-clockwise moment clockwise moment should be equals to 0. So we are going to do the same thing here. So we are starting from this W, which the same thing which we are looking for. So we're starting from this W. So this W, it is going to be multiplied. Like we know moment it is equals to force times distance, right? So in which it will be W times 0.25, then plus this 100 here, this 100 here, this 100 here, you are going to have, let me say 100 Newton, 100 Newton multiplied by the distance from this point up to here, it is 0.4, 0.4, right? In which here we're going to find W times 0.25, you're going to have 0.25 W, right? Then plus 100 times 0.4, you are going to have 40. And this one we can't add because here we have a letter, here we don't have a letter. So this is clockwise. When you take the moment on clockwise, because when you stand here, the forces will be going this way, which is clockwise. Then let's move to anti-clockwise. When we take the moment on anti-clockwise, we're going to say anti-clockwise, we're starting from here. So anti-clockwise, we're starting from this point, which is 300 Newton. This at the same time, which we're having the same force, which is 300 Newton, then times the distance which this force it is subjected to, which is 0.1, then plus for this 200 here, 200 Newton, it is this distance, which is 0.3. So 200 Newton times 0.3, right? In which 300 Newton times 0.1, it is 30, right? Then plus 200 Newton times 0.3, you are going to have let's say you are going to have 60, right? In which it will be 90. It will be 90. And the formula, it is clockwise moment minus anti-clockwise moment should be equals to 0. So we are going to do the same thing here, in which this anti-clockwise will be on the other side. So clockwise moment, we have found that it is this is a clockwise moment, which is we have found that it is we have found that it is 0.25 W plus 40, which should be equals to, when anti-clockwise across is equal to plus anti-clockwise. So anti-clockwise, we have found that it is 90, right? So it will be 90 here. Then when you subtract 40 both sides, you are going to have 0.25 W, which is the force which we are looking for here, right? Then plus, or because we are subtracting 40 both sides, so here we're going to have 0. So 90 minus 40, right? In which 0.25 W should be equals to 90 minus 40, you are going to have 50, right? Then here you divide by 0.25, because we are looking for 0.25 here. If you want for it to be easy, you can take this one into fraction, which is 25 over 100, and 25 into 100, it is 4, right? So this is the same as 1 over 4. This one, it is same as 1 over 4. So we can say W, it will be equals to 50, 1 over 1 over this one here, it is 1 over 4, right? 0.25, it is same as when you take it into fraction. So W, it will be equals to 50 over 1 times 4 over 1, in which W, it will be equals to 50 times 4, you are going to have 200 Newton, because we are looking for force. This is a force which we are looking for. Thank you for watching, and don't forget to subscribe and turn on the notification bell so the next time you may see the new update. This lesson is based on a moment in engineering science, and for those who are encouraged, this is your part of revision. And in the next topic, we'll be looking at stress and strain.